Good morning, Algebra 2s. Happy Thursday, January 30th, or Friday, January 31st. Your last video class lesson. I'll be able to see you next week. I'll be back on Monday. So for today's warm-up, what I want you to do is I want you to think about and compare each of these four problems. These first two are about exponents, and these next two are about radicals. And I want you to take for a minute a conversation over here on the side of your page. If you have an x to the nth power, and that's equal to whatever number value you have, you are going to use the inverse to undo that exponent by taking whatever root is necessary. When you take the square root of a value, the danger here that you want to watch out for is if n is even, you need to watch out for the plus minus and the I. If n is odd, then you just match the sign. So we've been doing this for a while. There's nothing new with this idea. Our newer idea comes from what you learned this unit, where if you have some number x, and that number is to the nth root, and that is set equal to some value, when you go to do the inverse of this operation, you're going to wrap both sides in parentheses, and you're going to take it to the nth power. So by taking it to that nth power, these will of course cancel out. That's why they're inverses. The dangers that you're finding here, or the tricky parts, is sometimes you have an extraneous solution, and then sometimes your radicals can be rational numbers or fractions. You can have fraction exponents, which has you doing a combination of both squaring or raising to a power or taking a radical. So you need to think about these big ideas, these two conversations, as far as what they're doing as inverses, and how each of these operations will undo each other. So you really need to, more than ever before, really think about what you're thinking about while you're thinking about it. Okay, let's talk about this problem. We're going to subtract 5 from each side, and that's going to leave me with 3x cubed is equal to 24. Divide by 3, divide by 3. So x cubed is equal to 8. That's going to be this story here, where I'm going to take the cube root of each side, recognizing that then x is equal to 2. I don't have to worry about a plus or minus because my index is odd. So if this was a positive, so is this. If that were negative, so would that be negative. All right, let's take a look at our second problem. We're going to add 2 to each side, and we're going to isolate my exponent expression. When we take the square root of each side, because this is an even root, you need to consider all of the possible solutions. So x plus 1 could be equal to plus or minus 3. That's going to give us two different scenarios. X plus 1 is equal to positive 3, so x is equal to 2, or x plus 1 is equal to negative 3, so x is equal to negative 4. So I have these two different solutions that are possible because when I look up here, whether this is a negative or a positive 3, when I square it, I lose that sign. That's why I have to make sure that I pay attention to any plus or minuses and I find that hidden solution. There's a potential missing solution here. There's a potential extra solution here. All right, shifting gears and talking about if I have a radical, my first step is going to be to isolate it. So we'll subtract 6 from each side. So the square root of 3x is going to be equal to negative 2. Now, I'm thinking ahead, this is not going to be possible. So I'm pretty sure here I'm going to get an extraneous solution. So I'm going to do all the right math because you'll see it'll work out. So the square root of 3 times x squared is going to be equal to 3x. Whatever's inside of that radical is just going to be my value, is equal to positive 4. So x is equal to positive 4/3. That looks like a fine solution, no problem, but I always want to make sure that I double check, test it, because I want to make sure that it works out. And the calculator is so easy for you to do this. So second radical, 3 times 4 divided by 3, and then close your parentheses or arrow out of the radical. And you want to plus 6. And then this says it's equal to 8, but we're looking for 4. So because it doesn't match, let me do that again. No, I think I'm okay. Yeah. This is going to be an extraneous solution. Okay, this last one. Our first step is, of course, to isolate the radical term. So this one has to go first. So 3 times the cube root of 2 times x is equal to 12. Divide by 3. Divide by 3. So I get the cube root of 2x is equal to 4. So because I have a cube here, I'm going to go ahead and raise everything to the 3rd power. These 3's will end up canceling each other out. So 2x is equal to 64. I'm going to divide by 2. Divide by 2. X has a value of 32. So I'll go back and I'll check that with my calculator. And I'll say 3 times the cube root of 2 times 32. And then we'll end that under the radical. Minus 1, and we got 11. So we're good. That answer checks. All right, so here's what I want you to think about right now is if you look at 1 and 2, they're similar. And 3 and 4 have a way of being similar. But then I want you to think about how 1 and 4 are similar. And I want you to think about how 2 and 3 are similar. So when I look at your papers, I'm looking for what you see, what you have as far as how each of these are similar. So if I were looking at each of these, 1 and 2, 3 and 4, both of them are going to require the same operation, whether I am taking a root or raising to an exponent. When I look at 1 and 4, what I see similar might have to do with what kind of power or root. So I'm looking for your reflections and your answers here and your thoughts. All right, here's today's tasks. you are to complete your warm-up and check it with the video key. That's where you are now. I want you to check your homework with the review sheet. And I would like you to reflect on where it is that you went wrong. That key is posted, so you should have no problem checking those answers for the review sheet. Then I want you to check in with Mr. McCulloch for the radical pyramid puzzle and solve the radical equations. Here is going to be your workspace. You're going to record your answers in those circles. And then you're going to follow the directions to build the pyramid. So if you look on the back here, each of those letters for those tickets, you're going to get scissors and glue. And then you're going to be able to place and check whether or not your answers are right by building this pyramid. And this is going to be your exit ticket for today. You have an additional review sheet tonight for homework, and we'll be posting the key to that. So good luck, algebras. Keep on working hard.